right, so let's kick it off. So I hope everybody's having a great day today, and thank you once again for joining today's webinar, where we're going to be exploring distributed SQL on Azure with Cockroach Labs. My name is David Joy. I'm a senior manager who leads, cloud solutions engineering team for our partners here at Cockroach Labs. And today I have a guest with me from Microsoft, Krishna, and we're going to have this session and this webinar talking about Azure and Cockroach Labs and what it really means for you as users who are trying to, build applications on the cloud. A quick agenda today for everyone. We're going to start by talking about some key trends and some challenges that we are hearing in the space today, especially for folks who are moving to the cloud and who want to, use and build, scalable solutions like CockroachDB. And Krishna is going to walk us through that a little bit. And from there on, we're going to get into an intro to CockroachDB, our technology, and we're going to do a little bit of a zoom in on what CockroachDB is and how you can actually use it in your day-to-day use cases. And towards the end, we're going to talk about CockroachDB and Azure and our partnership, and we're going to close with how you can get started. So I hope you guys are having a good day already. This is an afternoon time, so thank you once again for taking the time to join. If you have any questions, just some housekeeping is, please feel free to pop those questions in the chat, and we are going to address those questions. I have a teammate joining who is going to answer it, and also if there are some specific questions, we will take them and address them on the webinar itself. So once again, thank you for joining. Let's get started with like a quick introduction from Krishna. Krishna, thank you so much for joining. Why don't you let the people know a little bit about what you do at Microsoft?
Hey, good afternoon, good evening, good morning to everyone. So predominantly my role in Microsoft is an enterprise specialist, so technology specialist working with large enterprises that want to go into the cloud, help them in the cloud journey, and then building cloud scale solutions, predominantly on different types of Azure components, including CockroachDB. Yeah. Good to be here. Happy to support David and team. Looking forward for a productive session today.
Awesome. Thank you so much, Krishna. So for everyone listening, when Krishna and I were talking about doing this webinar, and we wanted to talk about really understanding and setting the stage up by seeing some trends and some patterns and some challenges that we are seeing with folks who are trying to move to the cloud. And so Krishna is going to lead us into talking about some observations that he has had working at Microsoft and working with all these enterprise level customers. So Krishna, I'm going to hand it over to you for a bit, and I'll move the slides for you. Thank you.
Yep. Are you good? Or
yeah, you can go.
Okay. So in a couple of key trends that's happening around the industry is about modernization of the legacy applications. Customers tend to have a lot of traditional or legacy applications that are sitting on premises. They want to move into the cloud. So that's potential opportunity we're seeing there. And not only that, so because of how the businesses are moving faster and growing faster, they also look for scaling up on demand, without you spending too much capital expense on buying large infrastructure. You just want to scale out only when you need it. On top of that, availability is becoming a huge topic because as systems grow, more components come in. The availability becomes sometimes challenging, depends on the architecture. So customers are looking at highly available systems which are fault tolerant and able to consistently make it available. That's on the other opportunities or trends I'm seeing is a lot of the customers are expanding globally. They might be having customers serving the world, so which means you need to have services and systems which are pretty much across the globe. With Azure is available over across all the regions of the world. So I'm also seeing expansion of the customer base, and accordingly the technology has to go for it. And also looking at regulations, there are new regulations coming in for compliance reasons and a whole bunch of things. And especially on a complex regulatory environment, there's also a need to have systems which are able to be compliant all the time and go from it. Another trend I'm seeing is consistent transactions, guaranteed consistent transaction. So this is also especially customers are moving the financial systems into the cloud world. That's guaranteed consistency of transaction becomes very key point too. So this is an overall view on I'm seeing in sort of trends across the industry, David. We can expand as we go along. Yeah.
Awesome. Yeah, Krishna, I just moved the slide. Yeah.
Okay. So how does customer like Azure helps in the cloud journeys, especially on we call hybrid, which means a customer should be able to run pretty much any critical system they want, either on premises or on the cloud, or basically a hybrid model. One trend we do see, as I spoke earlier, is migration or movement from on-premises world into a self-managed data centers into Azure. And not only that, right? Once they go into Azure, they immediately opens up opportunities like expansion. We have multi-regions of Azure, and customers tend to take advantage of that. And once they go into that model of multi-region deployment, architecting solutions which are global scale and also zero downtime. The zero downtime is achieved by Azure native components, BaaS components, things like CockroachDB, which is able to make them available across different instances. In combined with it, security, compliance, governance also plays a major role. So you have a solution which is deployed, and the security layer applies through Azure Defender products, Azure security products as well, and also audit control. So the journey of the customer varies, but in terms of the cloud journey, usually from on-premises or more in the cloud and then building into the cloud and then taking advantage of the regions and then architecting a highly resilient solution in adherence to the governance and security and data and compliance, things like that. So that's where I see cloud Azure is helping. On top of that, there are a whole bunch of things which Azure can do. So yeah,
That's
maybe
amazing.
anything you want to click on or
Yeah.
you want to just, yeah.
Yeah, I mean, I just wanted to say, I think back in the day, I mean, you take 15 years ago, 18 years ago, if a system was down for 5, 10 minutes or half an hour, you wouldn't really hear about it. Like
Yep.
like there would be an issue, but people would be like, well, this is how life is, right? But today, that's not the case. Like high availability and to serve a customer base and keeping them satisfied is table stake requirement for any business. And
Yep.
uh, and what we are seeing even on Cockroach as we engage with the cloud partners is that architecting for scale and zero downtime has become table stake requirement. So whenever we talk to any customer, they are from the very beginning talking about how can I architect for scale and resiliency, and that becomes like a everyday conversation. So that's something that I've observed, and when we work with our Azure partners, that's what we kind of understand as well, is something that we hear from
Yep.
our customers as well. So with that, now that you've understood a little bit of these challenges and some trends that we have observed and kind of presented here, let's talk a little bit about how CockroachDB addresses or and I'm going to walk you through what CockroachDB is and how we kind of tackle those challenges that we just presented. Now, the easiest way to tell somebody what is CockroachDB is that CockroachDB essentially is a distributed SQL database built for transactions workload for tier 0, tier 1 applications, the applications that require zero downtime, and they are mission critical for any enterprise, right? And it's consistent, resilient, it's scalable, and locality aware. Now you might say, David, this makes sense. You made this statement, a very bold statement, but is this really true? And my job on in today's webinar is really to walk you through, an understanding of how we really provide these four pillars that I'm talking about, and these bold claims that we are claiming here, and how we kind of provide that to you as a user who will be using CockroachDB. So let's go back in the history a little bit, and let's talk about how we kind of evolved CockroachDB and built CockroachDB. Now, if you're familiar with the database world, you know, for about 40, 50 years, the kind of databases that we used to use were categorized together as relational databases. And what these relational databases gave to the industry was a database that was strongly consistent, They were, transactional. They had capabilities like stored procedures. You could interact with the database through like SQL statements, which became the language of talking to data. And we also saw some really good, open source databases like Postgres SQL. And the requirement of these relational database was to serve transactional workloads that could, cater to those needs. But these patterns changed, and in 2007 and 8, came this era of NoSQL databases, and that came through the requirement for scaling up to the needs of where the data was. A very influential paper was written in 2007 and 8, the Dynamo paper, that led to the creation of databases in the NoSQL space. And what they provided was scalability. And you could do things like online schema changes or do rolling upgrades, and that provided like low latency performance. These were like distributed systems or distributed machines that work together in a cluster that could horizontally scale. And that was what we observed in 2008 and 10. And NoSQL database have a certain workload that they cater to. However, they come with a sort of like trade-off. And the trade-off is, if they give you scalability and all these amazing capabilities, they take off strong consistency at times, or the ability to do transactions with stored procedures or with SQL statements, because you have to communicate with these new SQL, NoSQL databases with a new paradigm of communication. Like it might be a document, or it might be a query language that doesn't support SQL statements like join, or create indexes and things like that. And then around 2010, 11, 12, as we got into the decade, we saw that cloud native became pretty interesting and very important, especially for folks who are trying to get out of their own data centers. What Krishna just presented is folks are still moving out of on-prem and to the cloud, and most of the requirements are around this ability for the customers really to be cloud native, right? And there's requirements now that they want multi-region abilities, they want highly available availability zones, and they need a distributed system and a distributed architecture for their applications that can scale. And cloud native is basically now table stake. And what we are observing for the last like 4 or 5 years is also this enterprise ready capability that enterprises want, where they want, compliance like PCI or HIPAA or GDPR or, DORA in certain areas. And data domiciling and data locality has become critical for enterprises who are trying to build applications for a global scale. And so what we did at our company is essentially looked at what these key abilities are and built CockroachDB to kind of bring together the best of all these worlds. That's why we say that CockroachDB brings together all the database capabilities that came before it, sort of like the new database that serves all these requirements of today's modern applications. And that's why we are the distributed SQL database of choice for folks looking to build a highly resilient system. Now, with that said, let's zoom in a little bit more. And if you have any questions, feel free to type those in the chat. I have my colleague here, Virag, who has joined, who will answer those questions in chat, and we'll also address them towards the end. So zooming in a little bit, right? CockroachDB actually is a database that feels like Postgres. So one of the first things I want all of you to understand is that when you communicate with the data in your database on CockroachDB, you're actually going to communicate it exactly how you would do in Postgres. That means SQL statements, inserts, joins, and the frameworks that support Postgres. Essentially, anything that developers have used in the past is compatible with CockroachDB. However, which we go a step further, because we scale like a NoSQL database. What that essentially means is that instead of having one instance of database, CockroachDB actually runs as multiple instances of compute that work together to form what is called a CockroachDB cluster. So essentially, instead of having one machine or one server serve the database requirements, we actually break that workload across multiple instances and form what is called the CockroachDB cluster. And this is the nature of NoSQL databases. And this is really a distributed system in a sense. And that's why we can scale like NoSQL database. That means you can go from, say, if you're serving an application that has 1,000 transactions for a 3-instance cluster. You want to double it up, say you want to do 2,000 transactions. All you need to do is add 3 more instances. So like that, you have horizontal scaling available with CockroachDB, which is essential for folks who are trying to scale. Now, you can actually not just scale within a single cluster in a single region. You can actually break this cluster across multiple regions too. So you can have like a 9-node, CockroachDB cluster, or 9 instances that serve the application, but you can have them serve across multiple regions. So you have a US region, you have an EMEA region and an APAC region. You can break the cluster up. So even when a certain region is not available, you can continue to serve the applications. And we're going to dive into that particular piece a little bit more. So, but I wanted you to kind of know that you can scale across multiple regions. Now, at the same time, you can actually also read and write from CockroachDB cluster from any of these nodes. So typically what we have seen in like some distributed systems is that you can actually read from any node. That means they are good at scaling the reads, but the writes are limited to one instance. So you create a architecture where you have a master and a slave in many ways. But in CockroachDB, we present a peerless architecture. That means every node in CockroachDB is actually capable of serving the reads and writes. So that means if you insert some data on, say, node number 1, you can actually select that data from any other node. You as a user will never really know which instance you're hitting, because the reads and writes are getting moved across all the instances. So you can insert anywhere, you can read anywhere, and you're not limited to like, I have to hit a specific node in this cluster. Now, at the same time, the database is actually highly consistent. What that really means is that if you do an insert, say to node 2, and it's like an insert into this table, a name for a dog, you can actually read that anywhere in the cluster. You can actually read it on node 2, node 3, or node 1. What we typically do is, once the transaction is made on the database, it is consistent across all the nodes. So you can read and write as well as stay consistent on any of the nodes in the cluster. Now, how is data made available though? Like you might be wondering, like, how does this really work? So let's zoom in a little bit more. So assume you are writing a record, into a table called dogs, and we're writing the names of dogs. Assume that, and it's a list of data. It's in a table. What we do is actually we look at this table record and we break it into what we call ranges, and these are like really small ranges, and these ranges are then actually replicated and copied on each of these instances. And typically, as a user, you can actually choose the replication strategy. The default replication is actually 3. So we take a table, we split it into small buckets, what we call ranges, and then we replicate them and store them across multiple instances. Here in this example, you are replicating it thrice, and the same thing will happen to the other data. And so when you're reading and writing to CockroachDB, you're actually going to split the data and write it across multiple instances. And this replication really enables us to kind of build high availability into our system. So what really happens is that now, because you have multiple copies of the same data on your cluster, if an entire node is not available, say a node 3 goes down, you can continue to actually access the data because it's available on the other nodes. And that's how we actually enable zero downtime. So for the application never really feels like a server is down. For it always sees a highly available, always on system. And just so that this question has come up in the past, right? Hey, but do I need 3 nodes? Do I need 6 nodes? 9 nodes? So in production, we recommend you to have a system that is more than 3 nodes. So you can have, quorum and other impactful system needs can be met. Like, we have some things that happen in the backend to enable this high availability. So you need to make sure that enough resources are available. So just be aware that in production, we don't recommend a 3-node, a cluster. You will have to have at least more than 3. A 6 and 9 is like a great system to start off with. All right. So the same thing happens when you do upgrades. So say you want to upgrade a node, you want to basically update the operating system, or you want to change the storage, or you want to do some specific changes to a particular instance. Even in that case, what happens is, because the copy is available on other nodes, you will have availability all the time. And the same thing happens when you're trying to make schema changes. And this is very important for folks who are developing applications that change a lot, right? And so in that case, what we have in CockroachDB is this ability to make schema changes live without actually making a downtime. And what we really do essentially is that we will make the change on a new version of the schema, and all the new data will be written to the new schema. And in the backend, the old schema copies the old data into the new schema, and it all happens seamlessly. And you will have zero downtime. So that's how we are able to kind of meet the requirements of high availability for folks who are building applications for the challenges and the cloud requirements that uh, Krishna mentioned in the beginning. Now, with that, just want to give a final two, concepts that I wanted to break down. Was you can actually read and write data across any of the regions as well. So while I presented the idea that you can read and write on a particular node and across a cluster, but when you design the application on the cloud, you will design it if you have multi-region requirements to run across multiple regions. So now you can actually read and write for a specific region. So if you have users who are in, say, EMEA, who want to read from the CockroachDB cluster, they can actually read from the closest instances available in their region that is in EMEA. And that ways you have a global cluster, but you can meet a local demand. And that ways you keep lower latencies, and you can keep your latencies as low as you want to serve your customer base. And we also extend this ability to serve the compliance requirement, where you can actually pin data down to specific geographies. And especially in EMEA, we know that there is this requirement to, have data be domiciled to a specific, region. That means we don't want the data, users are like, we don't want our data to move out of CockroachDB, EMEA cluster. So you can actually pin that down. You can specify that at a table level by saying that, hey, all my data for this particular table should remain exactly here, and it should not go to US or APAC, and you can like pin everything down. So just at a high level, as I made a claim in the beginning that, hey, CockroachDB is consistent, resilient, it's locality aware, and it's scalable. I hope you have understood how we are able to kind of provide those four key value props to you as a user, or to developers who are trying to build applications for scale. So I'm going to take a pause here. I'm going to let Krishna come in. Krishna, I know we have spoken about this a bit here and there. When you started learning about CockroachDB, what were some of the things that really excited you from what I shared? I think you're on mute, Krishna.
Yep, the class. So uh, there are a couple of key points which started my journey into the CockroachDB, right? So for example, when I work with large customers, so as you mentioned, right, most of them are global customers. They have multiple regions, multiple geographies. Within geography, they have multiple subsections of it, right? So the global scale and resiliency, for example, you could have a potential issue on your infrastructure or the code on one region, but at the same time, customers, as you mentioned earlier, right, they want to be served. So the global scale and ability to have a copy of the data without impacting your business operations also, that's one of the motivating factor. As you, when you, especially on the compute, on the storage and the compute and database world, scaling horizontally is where it's more fun thing than vertically, right?
Right.
Scaling horizontally means you can distribute your risk across the board versus if you're going to scale vertically, you're going to have more compute and cost. So that's one of the things in. And the key point you also mentioned is the strong consistency, right? That's where when you're building a database transaction application, financial application, things that that strong consistency plays a major role. And you know what, the fun part for me is ability. If it runs on Azure, you can link that service with other Azure services, the AKS, the storage, the other database service, OpenAI, and all the other things which
Right.
comes into play, right? I mean, if you put all the things together, I would say CockroachDB, the motivation for me to learn CockroachDB is from a data perspective, plus how it's able to take advantage of the ecosystem. My favorite part is like ability to scale across the globe.
Right.
And yeah, and the engineering behind it is also fun stuff too, right? As you mentioned, you can scale between 3 nodes or 4 nodes or whatever it is, and accordingly you can tune it. You have that's yeah. Those are my motivating factors to get into CockroachDB.
Right. No, that's great to know. And I hope you were able to learn something here about the way we have structured and architected
Yeah.
the product itself. And to what Krishna said, it's a good segue to helping you understand some of the top use cases on CockroachDB. And as I was just kind of conveying to you, like CockroachDB handles, a transactional workload for applications that have to be always on, mission critical application. And if you, some of our top customers, handle these use cases, for, user accounts or metadata to payments, and identity management to e-commerce inventory, who have these table stake requirements, where they have to build for scale. They have to think about resiliency and consistency. And here's a great example. About a couple of months ago, there was a World Cup going on, and in one of the finals, what happened was the app that served the World Cup viewing experience went down. And one of the craziest things happened that as somebody who is, somebody who doesn't typically go to Twitter, I ended up on Twitter along with all these other people who were unhappy with the experience and asking for money back. And that really affected that business. So it's table stake requirement to build mission critical apps that should always be available. And that's the kind of experience that we at CockroachDB are enabling our customers to build. And we're going to share some of this material out after the webinar. So if you have any questions, you can always reach out to us. But if not, I'm going to encourage you to, ask questions in the chat. I can see some questions have come in already. So we're going to answer them towards the end. All right. So with that, if you're an Azure user, if you're somebody who is, hey, primary cloud provider is Azure, I prefer to build on Azure. For you folks, we wanted to kind of open up a little bit more and help you understand how to get started on Azure with CockroachDB. Um, Today, we have two solutions available to get started. We have a self-hosted solution for CockroachDB where you can get our CockroachDB license and you can run them on Azure VMs or Azure Kubernetes Service, that is AKS. And you can even we are working towards looking at and exploring Microsoft Arc, where you can run on-prem as well as Microsoft Azure at the same time, because for some folks that's critical. So the self-hosted solution allows you to kind of run CockroachDB, but the catch is you'll have to like maintain and run CockroachDB yourself, and we have our team here to support you, as well as help you kind of put the best architecture together to kind of work on that. The other solution we have is Cockroach Cloud, which is a fully managed SaaS offering that we have that runs on Azure as well. And you can actually come in, select the infrastructure that you want to choose to serve your workload, and that will be managed by us completely. All you have to do is once you choose the infrastructure, we'll manage it. You just interact your application with the database, and everything is kind of handled by us. So these are like the two options available on Azure today. We also have, the products available to run on all 13 regions of, Azure. Currently, they're all going to support multi-region. We have almost 8+ integrations with the Azure, services, and currently it's available on the Azure Marketplace. And if you have existing Mac agreements, we align with that. You can actually use those to purchase CockroachDB on the Azure Marketplace. Just to help you understand what are these integrations, what are the other things that you do. We understand that you don't develop your application in a silo. You have to build applications to support an ecosystem of use cases that serve your applications, from business intelligence to AI, to streaming, and Fabric is a critical tool too for data analytics. So we are currently integrating with all the existing key integrations of Azure. Today we have tested ourselves with all these solutions that you see here, and we are working on streamlining and improving some of these integrations as well. So we are building the solutions to serve you on Azure with these other solutions that are important to you. For example, you might be somebody who's like, hey, I want to pull some of this data out of CockroachDB, and I want to then do some analysis on top of that. So CockroachDB today has a change data capture capability that allows you to stream data downstream and serve some of those other use cases that are important to you. So just wanted to share that as well. When it comes to choosing your compute, you can actually run us on Azure Compute through on the VMs as well as on AKS, as I had previously mentioned. And we can dive deeper into this if you want in a deeper session as well. So with that, I just want to say thank you for hopping on to this webinar and for learning about CockroachDB on Azure. We are going to share these materials out. We're going to now slowly step into Q&A and address some of the questions that you may be asking. We've already got some questions here. I'm going to let Virag come in as well as kind of tell me what these questions are, and we can answer it for you. And if you want to learn more about CockroachDB on Microsoft Azure, you can capture this, QR code, and this takes you to our webpage where you can either sign up for CockroachDB or you can access Microsoft Azure through the marketplace. We're also going to send these materials out to everyone. Hopefully, some of them meet your expectations, and if they are, feel free to reach out to us, and we will also send our contact information. So we're going to slowly jump into the Q&A. I'm going to let this, QR code stay here for you to kind of scan this. And Virag, if you want to come off mute and come on camera and kind of address some interesting questions that the folks are asking.
Absolutely. In fact, I've been just typing away. I've been already answering some of the questions. So you can see them in the answered section tab.
Okay.
And
awesome.
Right now I'm in the middle of typing another answer.
All right. So I'm going to stop sharing, and I'm going to bring the Q&A up on my slide. And let's see. All right. So the answered questions have gone. Okay. So we have some open questions. So I have a use case where I need to ensure low latency with multi-region. How can CockroachDB help? So that's a great question, right? So when we start architecting CockroachDB for requirements around multi-region, one of the key things that we address and ask is, what are your low latency requirements, right? And one of the best way to design for low latency is to actually pin data down specifically for your users to specific regions. So if you have users who are in EMEA, we would like you to kind of localize those tables to a particular region. So when those users kind of come and hit those tables, they get the lowest latency required. Now, there is a problem to be addressed in a multi-region system. And the problem is speed of flight and network, and the cloud providers, like Azure, they have built the ecosystem to provide maximum low latency as much as they can. But speed of light is physics that can't be solved. But you can actually handle those situations and those questions by addressing, the way you design your table structures. So I see Virag is also answering that. But for low latency, you can always, define, local tables and specify data to particular regions to kind of reduce the latency. Is there a difference in how we interact with CockroachDB self-hosted versus managed? That was the question that was asked. There is the difference in which how you access it. When it comes to using the query language, the platform available to you, you have exactly the same experience, but the a managed product is fully managed. So we have monitoring actually built into the cloud managed solution. Whereas with self-hosted, you will have to kind of build monitoring and kind of monitor it separately. So it's just that managed is a fully SaaS product. Self-hosted is a fully, managed by you kind of product. But to interact with the database, like creating the database, accessing the database, and the way you, build your application to interact with the database, that's going to be the same. The drivers are available on both the platforms and they serve the same experience. All right, so this is a question I'm going to let Krishna, you come in by Nigel, related to the IoT question. Does CockroachDB help with edge cloud data processing and storage, i.e., high-speed data at the edge, requires like long-term storage on the cloud? So I want to spin it up a bit where can you kind of expand on some IoT use cases that you have seen on Azure, and then I can answer the CockroachDB part.
So it depends on, especially on the IoT edge usage I've seen is like there is a retailer that is running offline stores on the data warehouse and things like that. And also, for example, a large telco that is want to process from a tower where they want to deploy some services to capture some metrics and then push it across end device management, whole slew of things in. Definitely, there are, depending on the use case, the network connectivity, we can have multiple choices. The first choice could be you can have a small instance of CockroachDB running on these devices because of the low footprint and then push the data across. Or not only that, right? So, and additionally, there are some use cases where they need, they want to reach the mothership every few hours. So depending on the use case, definitely there are multiple choices of connecting CockroachDB in conjunction with the edge devices into Azure Stack HCI or into the Azure Cloud directly here. So yeah, so there are multiple scenarios that we can go with it.
Right,
And
that's
one of
awesome.
the, yeah, so just one geo-partitioning, so because you can able to split the data database into multiple regions, CockroachDB can play a major role on connecting all the data and things like that. So yeah.
Yeah. And I know Virag also kind of brought this question up. Somebody had asked, um, IoT use cases and time series data require a specific way of how you store data, right? Typically, you will see that when you store the times in time series data, the timestamp becomes critical because you're getting, on the edge responses, say every 5 seconds or, every second. And so you're storing data with, time series. So with CockroachDB, the way you can handle that is by adding, a way of primary key in which you can have this distributed, because otherwise you can create situations of hot nodes where you might have a lot of activity going on in a particular range, and we can expand on that a little bit later. But without confusing you, when you're using IoT data or time series data, you may want to specify the time series primary key to open up and get distributed across multiple regions, and that's or multiple nodes actually, and that's something you will have to consider, but you can do that with CockroachDB. All right, so it seems like most of these questions have been answered. I just wanted to say thank you to everyone for taking the time to come on and spend this afternoon with us learning about CockroachDB on Azure. Krishna, I want to thank you once again for taking the time to come on as well as guest. For everyone listening in, Krishna is very active on LinkedIn and has a great community of folks where he evangelizes about Microsoft Azure and all the different things that Microsoft Azure is working on, from databases to generative AI. And we are partnering with Krishna and his team to develop more content and bring our partnership together. So you can go follow Krishna on LinkedIn. He has almost 15,000 followers. I do not know how he keeps up with that, but thank you once again for coming, Krishna. And if you have anything else that you want to leave the audience with, feel free to add it right now.
We have covered all the key points in. Thank you very much. In terms of the content is really good. So happy to answer, connect in LinkedIn, and then we can go from there. Thank you, team.
Awesome. Well, thank you once again, everybody, for coming on. Hope you have a great rest of your day.